To find the inverse of this function, we're first going to represent it in a more friendly way. So let's write this as y equals 2 to the x minus 4. We now need to switch the x and the y. So we're going to rewrite this as y equals x equals 2 to the y minus 4. Let's get the exponential part of it by itself. So we need to add 4 to both sides of our equation. Now we have x plus 4 equals 2 to the y. But how do we get the y by itself? We need to do a logarithm. So we're going to do a log base 2 on both sides. So this is going to look like log base 2 of what we already had, which was x plus 4 equals log base 2 of what we already had on that side, which was 2 to the y. We know that log base 2 and a base of 2, those are going to basically eliminate each other. So that means that now we just have that y equals log base 2 of x plus 4. Let's go ahead and try and graph this now. In order for us to graph this, it would be a good idea for us to find a few attributes first. Let's find out what the vertical asymptote is for this particular graph. Remember that we're graphing log base 2 of x plus 4. For this particular graph, it does have a vertical asymptote where this is 0. Because remember, we can never have 0 as an argument for a log. What that would mean is basically that we could raise something to a power and end up with 0. So when exactly would this happen? So it would happen whenever x plus 4 equals 0, or in other words, when x is equal to a negative 4. So our vertical asymptote is going to be at x equals negative 4. So let's find the x-intercept. For the x-intercept, we're going to remember that the x-intercept is whenever y is equal to 0. So in other words, our function has to equal 0. So what would that look like? Well, we would say 0 equals log base 2 of x plus 4. And remember that if we want to get rid of the log base 2, that means that we're going to use a base of 2. So 2 to the 0, because we already had 0 over here. And then 2 to the log base 2 of x plus 4. Remember that the log base 2 and the base of 2 cancel each other out because they're inverses. So we're just left with x plus 4. What about 2 to the 0? What happens whenever you raise a number to the 0 power? Well, we know that that's going to be 1. So now we can subtract 4 from both sides of our equation, and we end up with x equals negative 3. So now our x-intercept has to be where x is negative 3. We already said the y value was 0, so there's our x-intercept. So what about our y-intercept? Just like how the x-intercept we're setting something equal to 0, our y-intercept we're also setting something equal to 0. So for our y-intercept, we know that x is 0. So if we substitute 0 for x, the work would look like y equals log base 2 of 0 plus 4. 0 plus 4 is 4, so we're doing log base 2 of 4. In other words, we're asking what power, because logs are powers, what power would we raise 2 to in order to get 4? In other words, 2 to what power is going to give us 4? And we know that that has to be 2. So in other words, y has to be 2. In other words, log base 2 of 4 equals 2 because 2 to the second power is equal to 4. So what that means here is that our coordinate is going to be 0, comma 2. Now let's put this together to make our graph. We know that we have a vertical asymptote where x is negative 4. We know that we have a x-intercept at negative 3, 0. We know we have a y-intercept at 0, 2. So what exactly would the graph look like? We know that if we connected these 2 points, that it would continue to get closer and closer to our vertical asymptote, but never touch. And we know that if we continue the graph back this direction, it would continue to increase, but it would do so very slowly. So that's what our logarithmic graph looks like.